Let us cover the movements of the forearm. The movement occurs at the elbow joint, where the radius upper end articulates with the capitellum and the ulna upper end, consisting of the olecranon and the coronoid, articulates with the trochlea of the lower end of humerus. Since the trochlea is a hinged structure, it's a hinged structure like this, it will permit movement only on its axis, that means flexion extension. And it will not allow any other movement. That's why the elbow joint is a hinged joint. Now the triceps extends the elbow. The brachialis attached to the coronoid. We'll rub this off a little bit so that it becomes clear. The brachialis attached to from the coronoid to the surface of the humerus, and the biceps coming anterior to it from the long head of biceps and short head of biceps respectively from the supraglenoid tubercle and the coracoid process. So biceps and brachialis will flex the elbow. Extension triceps, flexion biceps and brachialis. Now let us look at the anatomy of the triceps insertion in a little bit of greater detail. But before that, when the forearm is mid-prone, the brachioradialis originating from the lateral supracondylar ridge and inserted on the radial styloid will also flex the elbow. Three muscles to flex the elbow: brachialis, biceps, and brachioradialis. Brachioradialis flexes in mid-prone position. Now we'll study the little bit about the insertion of the triceps. This is the triceps muscle. It's coming down and getting inserted onto the olecranon fossa. Olecranon of the upper end of ulna. So it's getting inserted here. This is the posterior border of the ulna. This is the posterior border of the ulna. And on the posterior border, on the lateral side, a muscle originating from the lateral epicondyle is getting inserted. And this is the unconeus muscle, which is a vestigial muscle because it produces no movement. On the medial side, connecting the olecranon to the medial epicondyle is the ulnar collateral ligament, and underneath the ulnar collateral ligament is the canal of Cannon, which passes the ulnar nerve. And since flexor carpi ulnaris originate from the posterior part of ulnar collateral ligament, the ulnar nerve comes to lie deep to the flexor carpi ulnaris and becomes superficial to the flexor digitorum profundus, which is arising from the surface of the ulna itself. So this about the flexors and extensors of the elbow. Now we go on to the pronation and supination. The pronation and supination occurs at the radioulnar joint. So there are three radioulnar joints: the superior radioulnar, where the ball is the head of the radius and socket is the upper end of ulna, and the inferior radioulnar joint, superior radioulnar, and then inferior radioulnar joint, where the ball is the head of the ulna and the socket is the lower end of radius. And as you always know that it's the center of the ball, that means center of the head of the radius to center of the head of the ulna, that the axis of pronation and supination will pass. Now, pronators. One is the pronator teres, arising from the common flexor origin, that means the medial epicondyle, and the coronoid process. So it has an ulnar head and a humeral head, and it gets inserted onto the radial side, radial border of the radius, and it will pronate the forearm. The other is the pronator quadratus, arising from the lower end of ulna attached to the radius, and it helps rotate the radius over the ulna. So these are the pronators. Now, one important thing about the pronator teres is that the median nerve, this is the median nerve, would pass between the two heads of the pronator teres. And this is the brachial artery. Is dividing into the radial artery and the ulnar artery. This ulnar artery will pass under both heads of pronator teres from lateral to medial, will cross the median nerve and lie under the ulnar head of pronator teres. So this crossing is very important, because in an operation which is called as Max Page's operation for VIC, chronic VIC, we release both the humeral and the ulnar heads of pronator teres. That's why this relation with the median nerve and the ulnar artery becomes extremely important. Now we will go on to supination. In an extended elbow, the supinator originates from the medial epicondyle and also from the posterior border of the ulna. These are from the humeral epicondyle are the superficial fibers, from the posterior border of the ulna, the deep fibers. It goes posterior to the head of the radius, and the upper part of the shaft of the radius winds around it. It comes to get inserted in the supinator crest, which arises from the radial tuberosity and goes through the radial styloid. The supinator, supplied by the posterior intraosseous nerve, will rotate the ulna, radius in relation to the ulna into supination. So this is on an extended elbow. Now if the elbow is flexed, you see the section of the radius here with the radial tuberosity and the coronoid process, which is forming the concavity in which the head of the radius is articulating. And on this radial tuberosity, on a flexed elbow, is inserted the biceps. So when this will pull the radial tuberosity up, the radius will rotate externally and will supinate. So since biceps is a very powerful muscle, therefore you always supinate with a flexed elbow. And that's why when you are tightening a screw, you flex the elbow to use the biceps when you are tightening a screw. So I would request you to keep your hand on the biceps, extend the elbow and see that while you are supinating the forearm, the biceps is not contracting, and then flex the elbow and then supinate, and you will find the biceps has started to contract. So this covers the pronation and supination.